Hello and welcome to this second workshop as part of our EduKits holiday coding experience. I'm your host Michael and it's exciting to have you back again. If you're joining us for the first time, welcome. If you were here last week, welcome back. Today we are going to be building two exciting new inventions with the amazing Annoyatron. We will be building the Button Master and we will also be building Wakey. I'll go into more about what these two inventions do later on in the workshop. But first, let's take a look at a few things. On your live stream page, you'll see a few things in the sidebar. Firstly, you can send us your comments live through our live stream email address, which is ls@edukits.co. We will be answering any of your questions or issues you're having through the email address later on in the workshop once we've built the inventions. Before you follow along, you'll need to download the Arduino software. If you were here with us for the last workshop, you would have already done this. But if this is your first time, you'll need to click on the box here for some instructions and that will link you to our page. Even though this is a live stream, you can pause at any time and resume once you've finished. If you have trouble understanding anything, you can always pause and go back. The live stream will still be there for you afterwards. And lastly, today we are working with a new app called Codekit. It's free and it's online. You can launch this down here under Launch Codekit, but I'll also show you another way to do this later on. Let's switch back to the main can. This is the instruction book that came with your amazing Annoyatron kit. Inside it is instructions on how to get started, including on how to download the Arduino software, which is here, and also the settings you need to change in order to have the line numbers, and those are here. I didn't go over this last week, but you can also find out more about what each of our components do. Especially the ones we're using today, which I'll go over now. Let's switch to the iPad cam, which will be working for us this week, I believe. Here we go. So, like last week, we have the brain board. It's brilliant to see that you guys can get up and close with these components this week. The brain board controls the inventions and it's what you upload code to. You will also need the buzzer. Looks like this. It has a hole in the top for the sound to come out of and it has two legs. One leg is longer than the other. And this is how we know how to connect this to the board. You will also need a touch sensor and it's this contraption here. It has three legs coming out of it and they're labeled and it also has a target shape in the center and that's where you touch and it detects when you touch right in the center there. To connect that touch sensor to the brain board, you will need 3 wires. Here we go. It doesn't matter what color they are because all the wires will work the same, but it's important to see that the wires have one side that is a hole and one side that has a pointy end. And these will allow you to connect them to your computer. Now, later on, you will also need a light sensor and a resistor, and that's for the Wakey project. So see here, we have just focus on that, we have a resistor. A light sensor, which is technically a light dependent resistor. And this allows us to sense when it's light or dark. You'll find out how useful that is later on. And this is a resistor, and we'll bend that into shape later. So now we have all the parts. It's time to figure out how to assemble them. After, of course, we launch Codekit and take a quick look at that. So jump onto your computer again. We'll head to the EduKits website on the homepage. Here we go. Of course, you can click the bottom right box to head to the Codekit website, or you can go under our EduKits home banner, code, and launch web app. We do have a desktop app you can download, but we'll be using the web app for today. It'll take a few seconds to load. It's loaded for me now, and you'll instantly see a quick settings box pop up. We have options for selecting the kit, which is the amazing Annoyatron, and we also have an option to change the appearance between dark and light mode. This is just down to personal preference. So if you like the look of one or the other, just select that and then hit get started. Don't worry about the advanced mode. So now you can see we have Codekit. We have options for all different things, but I will show you over here. You can click on different categories and blocks will pop up. These are what we use to code. And over here we have options for copying and downloading. So now you've got Codekit open, let's switch over to the components and assemble this invention. After that, we'll come back to Codekit and code it. Brilliant. So I will move our resistor and our light sensor away so that we have some room to assemble this invention. Let's start with the brain board. You'll remember from last week that we can connect the buzzer to the board by sliding the legs into the pins. So here, we need to go into the longer leg needs to go into pin number 11 on the board. And then the shorter leg will go into G and D. So get the longer leg and line it up with 8, and then you go 9, 10, 11. So if you count them up, if you count up as you're going, then you won't get into the wrong hole. Here we go. All you have to do to connect it is to slide it in. Perfect. We've got one part done. The next part is to connect the touch sensor to the brain board. To do this, you will need your 3 wires. I'm going to get 1 wire now. Here we go. Let's connect this first wire, get the end that is a hole, and slide it over the leg that says G and D. And you can see there are little labels over here where my thumbnail is. And these tell you what each of the legs mean. The pointy end, we're going to stick into the G and D pin over here on this side of the board. You can see that there are 2 of them and it doesn't matter which one you connect it to. Next, we're going to get another wire. Like I said, it doesn't matter what color you use for these, they're all the same. And we're going to slide this over the middle leg. Perfect. This one says VCC, and we are going to connect this to the 5 volts pin, which is next to the ground pins over here. But make sure you don't pop it into a GND and you pop it into a 5 volts. Lastly, we have 1 remaining wire to connect. I'm going to connect this to the SIG, which is short for signal leg. When we press down on the touch sensor, you'll see that obviously when we connect to power, a light will change on the little board, and a signal will be sent through this wire to whatever pin we connect it to. In this case, I'm going to connect it to pin number 8, which is over here on the brain board. Perfect. The final step to finishing assembling this is to connect it to the USB cable, which is here, and plug it into the computer. So, you may have heard me discuss last week, but my computer is a newer MacBook Air, not the MacBook Pro, and to connect it to the computer, I have to have a dongle because it's so thin it doesn't have the normal USB port. You might have to do this too. If you were here with us last week, you will have already found that out. So it's time to get onto Codekit and to code this invention. So what's happening with the button master? Well, we want to create an invention where we can make an annoying noise when we press the button. It's really that simple. I'm going to do this in 2 parts. The first part is going to be creating the annoying noise. We'll test that and tweak that. And then we're going to trigger it with the buzzer. So let's get started. Over here in Codekit, we can create code by dragging colorful blocks together, and the code will appear on the right for us to copy and paste into the Arduino application. So before, you copied code from the EduKits website and uploaded it, but today you can control what code that is. Let's go under the input-output section. You click on that section and blocks will pop up over here. Scroll down to the bottom and you can see options for the buzzers. We can select by clicking, holding, and then moving the cursor over here. We now have the set buzzer pin block added. And you can see instantly we have code added onto the right-hand side of Codekit. We need to change this to pin 11 though, because that's where our buzzer's connected. And you'll see we also have an option. It says 2 Hz 440. And that's just another way for saying frequency. So we can control how low or high pitched the sound is with this box. We've turned the buzzer on, and the next thing is to turn it off because I want to create a beeping sound. We can find that under input and output again, still at the bottom, and you can click, hold, and move the cursor down to add a stop sound on pin block. You'll see that when I move this close to the other block, a little yellow line appears below the first block and above the second, and that shows us that we can click those 2 blocks together. Perfect. I'll need to change its pin to number 11 as well. Before we upload this, we have to add a delay. Otherwise, this is going to turn on, and then instantly turn off, so we won't have any sound. We need to have a delay to let the sound go on. So you need to click on this settings icon up here and show the timing blocks. You can control which categories appear in the sidebar and turn on extra functionality if you'd like using this settings modal. Click close and your preferences will be saved. When Codekit reloads, which it has now, you will see a timing option in the left sidebar. Let's click on that and drag our wait block in. I'll pop this in between the 2 other blocks by clicking and dragging it there. So now we're waiting for 1000 milliseconds, which will leave the buzzer on for that long. Last week we talked about how 1000 milliseconds is equal to a second. I want this to be far shorter, so I will change this to 150 milliseconds, which is just over 1/10 of a second. I want another one of those blocks after the stopping sound, so we have a little break in between each beat. So I will right click, select duplicate, and drag the block underneath. I will give this a little bit of a longer delay, so 350 milliseconds, and you can see our code has automatically generated in the right-hand side. Now that we have the code, if you remember from last week, we can copy that and put it into the Arduino application before uploading it. For those who are with us in this workshop for the first time, once we have created code, to send it to the brainboard and to have it work, we have to upload it. So over here, you can see in the top right corner, we have a copy code button. If you copy this, a small notification will pop up in the bottom right corner. You can't see it now, it's gone because I'm covering it, but that will let you know you've copied it to the clipboard. Then go to your Arduino application, either create a new document, which is up here under the new section, or use an existing one, delete all the code by selecting it and hitting the backspace button, and then right click and paste the code in. You'll see that this matches the code that's in the Codekit window over here. Now it's time to upload, and before you do that, you have to go Tools, Port, and Arduino Uno from the from the top menu bar. Click on that. Now you've got your port selected and you can upload. You may have to save your file if this is, if you haven't saved it before. It doesn't matter what name you give it. And you can hear that we have an annoying noise. Perfect. I'm going to disconnect it from my computer for now while we add the button functionality. As always, you can just unplug it if it gets too annoying. Let's switch back to Codekit and trigger this sound from the button. In Codekit, we can have code controlled by some kind of condition, and this is done through an if block. So we can say, if something happens, then we can do this code. So I'm going to go under logic and I will click and drag this if block. Now I'm trying to put it slightly above the top block, and you can see that when I do that, it kind of wraps around the other block. So when I drop that, you'll see that all the other code is already in this if block. Fantastic. So now we can say if something happens, so we'll want to say if the buzzer is pressed, then we can make this annoying noise. Let's go under Input Output, scroll down to the state of pin, and click and drag this into the matching hole, because these things have shapes to show you where you need to put them, over there. Perfect. Now, we plugged the touch sensor into pin number 8 on the brain board. This means that when we touch the touch sensor, when you put your finger on it, that will send a signal over to pin number 8. And that's exactly what we want to sense for. So if we have a signal on pin number 8, then we will make an annoying noise. If you take a look over here in the code that's been generated, all of this tone, delay, tone, no tone, delay, and even the if statement, that's within the loop, which means this will go over and over and over again. It will essentially beep the whole time that you have your finger pressed down on the button, and when you don't, it's not going to make any noise. Perfect. Let's copy the code and test it out. I've clicked the button again. I'm going to delete all the code in my document. I will paste it back in and hit upload. As you'll see, we have an error down the bottom, and you might get these sometimes when you're creating code. Generally not with Codekit, but sometimes when you're making Annoyatron inventions and you've modified the code. When it says problem uploading to board, the first thing to check is whether or not your board is connected to the computer. Right now, my lights are off on both the board and the touch sensor, which means there is no power. I'll have to reconnect it to my computer before I can upload. The annoying noise is back, so I know it's working. I can click the upload button and the new code will be sent. You can see down here there's a message that says done uploading, which means the code has successfully uploaded. And it's not making any noise, which means it's worked. I'm going to switch over to the iPad cam to show you how this is working. Perfect. Now we have the brain board here and we have the touch sensor. And you'll see just then the code in action. When I touch down on the touch sensor, which is the target icon, it makes sound, and it is quite annoying. You'll notice that there is a little bit of a delay between when I press the button and I make the sound, but that's only got to do with the iPad cam. It's going over Wi-Fi, so it's got just a little bit of delay being processed by the computer. But that should be instant for you. Now, we have got something even more annoying for you in store today, and this is called the Wakey invention. This invention is pretty similar to the last one, but instead of having the annoying sound being triggered by a button press, it is going to be triggered by light, which means you can put it in a dark room, and when someone comes in and turns the light on, it will make annoying noises. Also, it means that if you put it in someone's room at night, not recommending that you do this, but just saying you did, and it got to morning, at the crack of dawn, this person would be woken up by an annoying noise. As I said before, don't do this. Bad idea. Anyway, it's time to build this invention. I'm going to disconnect the brain board from my computer and we'll switch to the iPad cam once again to show you how you can build this. So we have the brain board here. And I will need to disconnect these wires so that we can have the rest of the brain board free. Now it's time to connect the light sensor, which is here, and we'll also connect the resistor after that. On the EduKits website, we have instructions for how to connect these, and I think these would be useful to show you, because Wakey is actually an invention we have instructions for, but not for Codekit, just the assembly, because on the website we have the text-based coding one. Here we go. On Wakey we have a picture, and you can find this under the inventions page. I'm going to zoom into the diagram and show you the parts that we're interested in, because we've already connected the buzzer. So down here we have the light sensor and the resistor. You'll need to see that we need to put one leg of the light sensor into the 5 volts and the other one into A0. For the resistor, we need to connect one leg into GND, ground, and the other into A0. So 2 legs will be in the one hole. So let's switch back to the iPad cam and you'll be able to see me put this together. Let's grab our light sensor. And like in the picture, you'll need to connect this to A0 and 5 volts. What you do is you line them up and then you push them in. Now it's important to make sure that even though these legs will bend a little bit, you don't want to have them touching. And it looks like I put this leg into the wrong hole. Perfect. Oh wait, no I didn't. It's meant to... Yes, it's meant to be in 5 volts. Perfect. Now, we have the resistor and it comes straight in your box, but obviously not as wonky as this one because I've already bended this before. You will need to bend one side down and the other side also down until you have a shape like this. And that will allow you to put it into the holes. Perfect. Now, you want one to go into A0, which we had before, and the other to go into GND. Here we go. One side in here, one side in there. I've pushed down and those are now connected properly. You can bend it slightly out of the way so they're not touching, and we now have an assembled invention. Now it's time to get coding. Switch back to Codekit. Perfect. Wonderful. We can use very similar code to create the Wakey invention because it uses an if statement as well. An if block. Before we were saying if we have a signal coming through pin 8, which means if we're pressing the button, we'll make an annoying noise. But this time we need to test if there's light or not. And there's a block for that. So I'm going to click on the state block, delete it, go into input and output, and click and drag the light block, which is over here, the light sensor. We can click and drag this into the if. It says if light sensor senses light, we will do this code. So let's test that out. I'm going to copy the code once again, go into the Arduino application, select all the code, delete it, and paste it in. Let's click the upload button, make sure your board is connected, and you'll hear an annoying noise. That's because we've got light on. Now, I'm going to turn the lights off in the room, and we'll see if it works. Okay, clearly the lights are not dark enough in here. Oh, there we go. I've kind of cheated here. We can't get it dark enough in this room because there's like 8 lights on me at the moment, but I'm covering it with my hand so that the light sensor isn't having any light. You'll see that when there is light, it makes noise. So if you want, pause this video, go run to a room where maybe you can close all the blinds or something and test it out because it's super cool. I'm gonna unplug this now so I can actually talk to you without it trying to interrupt me. And let's go back to Codekit for a moment. We have built all the inventions we have on the program for today, but I'd like to tell you that there is heaps more you can do with Codekit in your own time. We won't be using it in the next workshop. We've got some other exciting things to try out with the Annoyatron, but you can use Codekit in your own time. If you want, there are more tutorials and informational videos about Codekit on our EduKits YouTube channel, which you can find just by clicking the EduKits avatar in our, actually, I haven't got the tab open anymore, in our live stream video. You can also just have an experiment. We've only really gone through 1, 2, 3. We've only used blocks from 3 of those categories, and there are heaps more. You can find loops, color, text, functions, and you can also turn on more over here in the block loader in the preferences tab. Now it's time to go to your questions, and there will be about a 30-second intermission while we load those up. So now we're on to the Q&A section of this workshop. The workshop has already gone for about half an hour, so if you need to go somewhere, of course you can access this live stream again later, but we are going to go on for a little while longer so that I can answer some of your questions today. The first question today has come in from Bella. It says, in Codekit, why don't we have to say if the light sensor is on or off? Great question. So, as part of our code, we only had an if statement for if light sensor senses light. But the code still does something, so it makes sure that there's no sound when the light sensor is off, so when it doesn't sense light. Let's go through exactly how that works. So in our code, if the light sensor is on, we will set the buzzer to make some noise, we'll wait a bit, we will stop the sound, and we will wait again. All of this happens in a loop, which means it happens over and over and over again. So if we don't have light, nothing is going to happen because none of this code in here is going to execute. If we do have light, and then the light goes, there's still going to be no noise made because at the end of our sequence here, we turned off the sound. That means we don't have to test for there being no light because our test for light handles everything. The next question is from Rabi. I hope I pronounced that name right. It is, why do we have to use a resistor? And that is another great question. Well, if we take a look at the parts here, there are actually two that we connected over here on this side of the board for this invention. There is our light sensor and a resistor. And actually, there is there are actually two resistors because our light sensor is a form of resistor. A resistor is quite complicated to explain, especially seeing as we're doing a lot of coding and not much electronics. But essentially it's there so that we change the signal coming through these pins, coming through the pin to, based on how much light there is. So that allows us to tell the difference between light and dark because there's a different voltage going through the pin, which in this case is A0. And we're able to measure that. And that's what the light sensor block is doing underneath. In fact, if you look at the code on Codekit, you can see under bool is light. So this is the function where it tests whether or not there is light. This is some fancy schmancy code here. It reads the pin, analog read, and it sees if it has a value over 300. So that is what the resistor is helping with. Next question from Amelia. What is your favorite buzzer pitch to be really annoying? Well, there are lots of pitches you can select within Codekit. I really don't have a favorite because I think they all have their place. You can have a low-pitched buzzer sound, which you can select by setting a lower value, maybe something like 150. But you can also have a really annoying high-pitched buzzer pitch, which you can create by setting the frequency, that's the box with the number on the right-hand side, to something higher, maybe 600. And you can see that automatically updates in the code. Next, we have a question from Bashar. And it says, with the touch sensor project, how could I do it in reverse so that the alarm goes off if people take their finger off the sensor? Perfect. I can show you now in Codekit. Let's delete the light sensor light. And I will add the, it's over here, there we go. The state of pin, there we go. We want pin number 8. So this is the code we had before. It checks if we have a signal coming through pin 8. However, I want to see what happens if we're not pressing it. So right now, nothing's going to happen. But we can change this. So we can essentially flip the value coming through pin 8. So we can say if pin 8 is, if pin 8 has a signal, then we'll pretend it doesn't. So we can flip that. So we can, under the logic, you can click and drag this kind of comparison block and place it in there where the other one used to be. Now, you can click and drag state of pin into this first one. Let's go back to 8. Oop. And then we will need, oh no, it's under logic, select high. Perfect. So this one says if state of pin 8 is high. So if we are getting a signal through, we do this. But the handy thing about this block here is we can change it from equals to the not equals sign, which is the equals sign with a diagonal dash through it. Now, this code will execute only when you have your finger off the buzzer. Perfect. Now, we have a question from Samuel now. And Samuel asks, is there a positive/negative leg on the light sensor like the buzzer? Or doesn't it matter which leg goes in which hole? Thanks, Samuel. So it doesn't matter which leg the light sensor, which leg of the light sensor goes into which pin in the brainboard. They're both the same, and the same goes for the resistor because they're both resistors. It doesn't matter which one you put them in. So go for your life. There's no right or wrong with that one. Now we have a question from Mediha. Now I hope that's the correct pronunciation. In the Arduino software, the port button isn't working for me. What do I do? So I went over this before, but it's really important that you check if your Arduino board has lights on it, because if your Arduino board isn't connected to the computer, you can't upload code to it. Over here on the brain board, my board has no lights on it, which means, I should stop covering my face with it, which means there's no power to it. So if you connect it to the board, you will see that we now have lights, and that means we have power. And you can now see that it's making noises. So if the port button is grayed out, it generally means that you haven't got something connected to your computer. And I would suggest, if you don't see any lights, you may have to apply a little bit more force to try and push the cables together, because sometimes they don't go fully into the port. Check it on both the side of the brain board and your computer, and then try to access the port again. Of course, if you are still having problems, just send us another email and we'll be able to get in touch with you and work with you to get the code uploading again. Wonderful. That looks like our Q&A session is wrapped up for today. As always, if you have any more questions, head to the EduKits website and fill out a contact form, or email us at ls@edukits.co, which is our live stream email address in the sidebar for today's stream. It's been a pleasure having you all on the stream today. I hope you've really enjoyed yourselves. Have a wonderful week. Until next Thursday, I'll see you later. Thank you.